Hello, welcome to a new Design Automations podcast series, Thought Leaders on the Future of System Design and EDA. We have been discussing design automation related challenges with our esteemed panelists. My name is Krishna Banka, your host for this podcast. I have over 2 decades of association with semiconductor and EDA industry, having worked with companies like Synopsys, Cadence, Agilent, and Keysight. My guest today is Hemant Shah. Hemant is a PCB design automation industry veteran who is currently the chairman of the IPC 2581 consortium, a consortium of over 120 companies dedicated to getting the standard adopted. Welcome to the podcast, Hemant. Why don't you introduce yourself to our audience? Tell us about your professional journey.
Thanks, Krishna. Happy to be here. So I'm Hemant Shah. As Krishna mentioned, I'm the chairman of the consortium of companies that are dedicated to getting IPC 2581 standard adopted. This consortium was created in 2011, and I had the honor of leading the effort then as when I was with Cadence. So prior to this effort, or this effort starts from 2011, but I worked for Cadence from 2001 till 2020, year 2020, right before COVID hit us. So I've a long history of working in the PCB design automation space, starting back from Intergraph days onto Harris CDA, onto Zynedex, then to Cadence. I've seen a lot of changes in the industry since that time, so we'll be happy to talk about that as we go along with this.
Cool. So why don't you talk us through your work in the standard space? What is the motivation behind your efforts? What is the kind of detailing that you guys go after?
So it's an interesting question. So back in 2011, there was a need for the industry to find a way to improve the way design houses handed off their design to manufacturing. At that point in time, 95% of the handoff to manufacturing was done through a format called Gerber. Most people in the PCB industry know Gerber-based packages very well, but this format was created back in 1950s or 1960s. Can you believe this? We are in electronics design automation space, and the industry wants the latest key capabilities, wants the tools to help them design a phone with the camera inside and all the capabilities, all of that, right?
Right.
And now we're getting on the AI stage, yet 80-90% of the handoffs to manufacturing is still based on format that was invented in 1950s, 1960s. So at that point in time, we collaborated with about 10 to 12 partners while I was at Cadence. And we talked to them about this problem, and they mentioned to us that there is a standard with IPC called IPC 2581. Unfortunately, nobody was producing because nobody was consuming, and nobody was consuming because nobody was producing. It was a classic chicken and egg problem. So what we did was we talked about 10, 12 companies and said, let's get together and change this chicken and egg problem by having representation from complete PCB design and supply chain design chain ecosystem. So design houses, the software companies like Cadence, Mentor, Altium, et cetera, providing software to the design houses, then to manufacturing companies and the companies that provide software to manufacturing companies, et cetera. So we got all of those representations together and started with 12 companies and basically started promoting this standard as a nice, intelligent way to communicate the manufacturing intent. And the beauty of this was this is a standard, not something that a software vendor owns. It wasn't a proprietary format. It was open, and so it can be by the people for the industry, right? So it was really that beautiful in that sense. And so we started with that. And we're happy to say in 2013 or 2014, first few boards were manufactured using IPC 2581. And now, as you know, as you mentioned in the introduction, that's 120 plus companies have joined us. And initially, we used to go after the companies to join our consortium. And today, companies come to the consortium and say, I want to join because I believe in this open standard. I believe in nobody owning this format and in this critical stage of handing off to manufacturing. So that was the background, that was the context, and the companies are all motivated to solve this problem. And there's a lot of innovation that has happened as a result of this openness. For example, this standard became from handoff standard to a bidirectional standard. So we first started by innovating a stack-up only exchange, which is very important if you have high-speed content on your board. And that process was manual, spreadsheet, PowerPoint based. So from that to bidirectionality started the stack-up exchange, but we also added another exchange, which is called the DFM exchange, which allows the manufacturing companies to provide DFM feedback to the handed off design electronically that is interpretable by the tools. I mean, Excel, spreadsheet, PowerPoint is all electronic as well. But this is an important distinction, is that the feedback is interpreted by the tools, PCB design tools. And so that's the second bidirectionality. And that's kind of the innovation that happens with this standard.
So that's perhaps the right kind of innovation which is probably required for PCB manufacturing and system design. As you rightly pointed out, that there is a need of standardization in the way these things are done, specifically when you're talking about handing off the masks for manufacturing. So I think at that point in time, definitely a standardization was definitely needed. And I think you guys have been working quite a bit in that space. So definitely there will be improvements. Now, perhaps the next question that comes to my mind is, how is your consortium helping the industry to change? Because we know it, right? It's very hard to change old habits, and more so in the semiconductor and EDA space. So how are you helping the industry to change its habits?
Yeah, so what we do is, consortium is a very good place for companies to come. Companies that decide to go onto this path of transitioning from Gerber to 2581, they need help. They need help in many different ways. Often what happens is large companies, manufacturing companies that these design houses work with, have an internal initiative to support 2581, but they have not trained their worldwide sales teams and manufacturing engineers, et cetera. And so the information isn't widely available within a company that even builds boards using 2581. So the consortium has a good connection with all of the consortium members, companies in the manufacturing space, the key architects in those space. And so influence, people who influence the decisions and the people who make the decisions. So if it's a design house is trying to go down that path and it's running into some roadblocks, either the company supports it, doesn't know it, or a company doesn't support it. Consortium has a lot of connections and a lot of influence in helping those companies to accept 2581. So that's one aspect we help. Then there are times where designs which were built and targeted for Gerber were really tweaked to maximize Gerber's capabilities.
Mm-hmm.
But those are not intelligent capabilities, because Gerber is a dumb format. It's a mask, right?
Right.
And mask can only have so much information. So people manipulated that. So then their designs carry some manipulations that can only be understood by Gerber.
Right.
So they need to understand what happens when they bring those designs to 2581. And there are better, intelligent, more efficient ways to deal with those situations they were dealing with. And the consortium's experience of having gone down this path is what's shared by consortium members with companies. And this is independent of whether they're in the same space or not. So one of the concerns a lot of people have, would a competitor that's on the consortium help me? The answer is yes, because this is not proprietary. This is not an IP. This is just simply a more smarter way for the industry to go about handing off designs to manufacturing.
Right.
A lot of different helping hands.
Definitely.
The consortium also, innovates because you now have representation from all the different companies in the ecosystem. The innovation is much better. is not limited to a software company's view. And software company doesn't live the manufacturing world, doesn't live the design space, right?
Right.
So the experience of those people comes into innovation. And so that's the other help that happens, is that innovation, like I mentioned, the bidirectionality was an innovation. And that happens because the industry representations came together.
Right. So I think one of the pertinent issues that we have been quite concerned with is the designer's productivity. Now, when we're talking about this kind of a standards work in the manufacturing, on the manufacturing side of things in the semiconductor space, so what do you think are the pertinent issues specifically related to the designer's productivity, and how can such feedback from manufacturing help the entire design process?
That's a great question. I think the bidirectionality helped us to think about what we can do with the analysis that the manufacturing company does. One simple example is that often what happens is the manufacturing companies have certain parts that they buy.
Right.
A design house may request a particular manufacturing part number, and that may not work because of availability, the price, and the tolerances of these parts. Just take the example of some capacitors and resistors, because you have tons of capacitors and resistors in a board. And a manufacturer may suggest an alternate part. Now that alternate part may have specifications which are very similar, but slightly different, right? Maybe the temperature gradient may be different. So now you're talking about replacement of a part at the manufacturing stage. That feedback has to go back to the designer at the very beginning of the stage.
Right.
And that designer then has to simulate or do whatever analysis they need to do to say, if I replace this part, what I specified, with manufacturer's suggested equivalent part, is that gonna be better for my design from a reliability perspective, or from sustainability perspective, or for being able to update the design later on? So that feedback loop really brings back to the very beginning of the design cycle, at the system level design, where designers choose parts for a particular intent. And that particular part works well with all the other parts selected. Now, there's a little bit of analysis that the designer has to do. So it's an important feedback loop. There are other important feedback that can come in. For example, later in the manufacturing stage, if the assembly is taking a lot more time because a particular part's physical characteristics are different, the manufacturer may say it may be too late for this particular design, but for the next iteration of this design, when you do a iteration with reduction in cost as an intent, you might want to replace this part with another part. Now you're taking that feedback again all the way to the beginning of the design cycle. So this is a great way to take feedback from manufacturing and influence your system level design.
Right. So I think the point that you just made is very relevant, specifically even for the system level design, right? Because system level design, as you would agree, lacks automation. Although rest of the semiconductor flow has benefited immensely from the automation, but system level design has lagged behind electronics design automation umbrella. So I think the kind of feedback that you just talked about, I think it will definitely help the entire semiconductor design chain, starting right from the system level design, and make it more deterministic, so that the entire design process can converge faster.
Correct.
Well, so just to summarize, I think PCB system level design has been going through a transition, and plenty of work is happening in the standards space, which has enough potential to influence the electronics design chain, and even as early as system level design, to improve the overall system quality and reduce overall costs. Well, wonderful conversation, Hemant. Thank you again for your time. That concludes our podcast. Any topics that you would like us to cover, please leave a comment. Thank you everyone for your attention and have a great day.